Hey, you just finished the first test review, working on the second one. Proud of you. Good job. Here we go. Let's see what we can do. First one specifies non-calculator. You're in a hot air balloon. You look at Steve with an angle of depression of 30 degrees. So you're up in the air. Whoop, you got this big hot air balloon. And you're looking at Steve with an angle of depression of 30 degrees. So you can draw it as an angle of depression or elevation. But angle of depression would be 30 degrees below a horizontal line. Your elevation is 1,200 feet. How far apart are you and Steve? So you and Steve would be the hypotenuse. Call that x. What is the horizontal distance between you and Steve? Horizontal distance better be a horizontal line. I'm going to call that y. So this is non-calculator for a reason. Why? Ding, 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 30 degrees. So this is the short leg. This is 1 root 3, 2. We have the short leg is 1,200. That means the long leg would be 1,200 root 3, and the hypotenuse would be 2,400, right? Times root 3 times 2 to the short leg. And there's our answers. Non-calculator, the legs of a right triangle are 24 and 45. So we have a right triangle. Those are legs of 24 and 45. What is the length of the hypotenuse? So if I had no calculator, I would certainly reduce. I can divide both of these by 3. I don't know if I can go farther than that. 24 divided by 3 is 8. 45 divided by 3 is 15. Oh, we need to know this. The hypotenuse would be 17. But since we divided by 3, we need to multiply by 3. So 17 times 3 would be 51. That's the number we're looking for. Write your 4 main triples. Do you remember what they are? They are 3, 4, 5, 5, 12, 13, 8, 15, 17, the one we just used, and 7, 24, 25. Make sure you know all 4. You need to be ready to use any of the 4. Given 3 sides, which sets of side lengths would form a triangle? So to be a triangle, this is all that has to be true. A plus B has to be bigger than C. So let's go through and see what happens. A plus B, 6 plus 3. Is that bigger than 10? No. 4.1 plus 5.1, that would be 9.2. Is that bigger than 10.2? No. 6 plus 10, is that bigger than 13? Yes. And then 12 plus 18, is that bigger than 25? Yes. So both of those would be triangles. Determine if the side lengths would form a right triangle, obtuse triangle, or an acute triangle. Select not a triangle if the lengths would not form a triangle. All right, so how do we tell? If a squared plus b squared equals c squared, we have a right triangle, yeah? So let's think about this. You got a right triangle. This is where C hangs out. What if that right angle got bigger? So let's say it's like 100 degrees now. What would happen to that hypotenuse, C? C would get longer. So what does that mean? If a squared plus b squared is smaller than c squared, if c squared got bigger, you know it's obtuse. And then the flip of that, if a squared plus b squared is bigger than c squared, it has to be acute. So these are the rules. So we got to test it out. First, is it even a triangle? Yes, 5 plus 6 is more than 7. So yes, it's a triangle. So we do 5 squared plus 6 squared. That'd be 25 plus 36. That would be 50, 61. So it's 61, and then 7 squared is 49. So that means that it is acute. C squared is smaller. It is an acute triangle. Here, and I told you that if it has a square root in it, you can assume it's going to work. So this one, we know it's going to work. So square these numbers out to figure out which one's the biggest. Well, 9 squared is 81. I got a feeling that's the biggest. 3 squared is 9. What is this? This is 2 root 22 times 2 root 22. That's 2 times 2 is 4. Root 22 times root 22 is whole number 22. That is 88. Whoa! So actually, this is my C. So what is 9 plus 81? That's 90 versus 88. 88 is smaller, so it is acute. This is my C squared. 88 is my C squared on this one. And that's smaller. That makes it acute. Well, that's fun. That's cute. Here, oh, these are big numbers. What's the first thing I should do here? And I probably could, no, I couldn't. I know I can divide by 4. That'd give me 11, 20, and 12. That's a lot easier. A lot easier. First, is it a triangle? Yes, 11 plus 12 is more than 20. So I divided all of them by 4. I'm going to do my numbers on that. So I'm going to do 11 squared, 20 squared, and 12 squared. That'd be 121, 400, and 144. So I'm going to add the two smallest ones together. That'd be 265 versus 400. Well, 400 is way bigger. That is going to be obtuse. Over here, we're going to square the numbers out. That's going to be 25, 64, and 39. Add the two smallest ones. That's 50 plus 14. That's going to be 64 versus 60. Oh, that's exactly equal. That is actually a right triangle, my friends. So that one's a right triangle. And then last one, 3 plus 4 is equal to 7. That is not even a triangle. It has to be more than 7. Find the area of the following triangle, round to the nearest tenth. So one of the things we learned earlier is that if you have a triangle and you know any two sides and the included angle, you can do 1/2 AB times the sine of C. A and B can be any two sides, but angle C has to be the angle in between them. Do we have that here? Yes, we do. This would be 1/2 times 8 times 11 times the sine of 70. If this was non-calculator, you could do 1/2 of 8 is 4. That'd be 44 sine 70. But you type that in, 44 sine 70, and I get 41.34. So rounding it to the nearest tenth, that'd be 41.3. Does it matter what order you put the 8 and 11? Nope. Does it matter where you put the 70? Yep, it better be after the sine. All right. Determine the following ratios. So if you're just doing ratios, I always recommend just reducing the entire triangle right away because your ratios need to be fully reduced. 9 divided by 3, 12 divided by 3, there's my hypotenuse. So the sine of angle A would be opposite over hypotenuse, 4/5. The sine of angle C would be opposite over hypotenuse, 3/5. The cosine of angle A would be adjacent over hypotenuse for A. And then, of course, the tangent of angle C is going to be opposite over adjacent for C. But if you have this triangle, it's already all reduced. Non-calculator, they gave us instructions on how to make a triangle. We have a right angle. It's going to be a right triangle. Cosine is always adjacent over hypotenuse. It doesn't matter which angle we call theta. I'm going to call this one theta. That means the adjacent leg would be 3 and the hypotenuse would be 7. So we need to do Pythagorean theorem. That would be 49, or let me write it out. That'd be 7 squared minus 3 squared. That would be 49 minus 9. That's the square root of 40, but hold up. We have to simplify that. The square root of 40, pull out the biggest perfect square. That'd be the square root of 4 times the square root of 10. That is 2 root 10. So this side would be 2 root 10. So what is the sine of theta? Well, sine is opposite over hypotenuse. That would be 2 root 10 over 7. So this was instructions to making a triangle. You build the triangle out, and you can do Pythagorean theorem to find the third side. What is the angle of elevation for the line y equals that? So we talked about this in class briefly, but as a quick reminder that this is a slope, right? This is your rise over your run. I'm not going to graph that out perfectly, but let's just get kind of close. You're at negative 15, right? And you're going up 11, right 12. So you go up 11, what would that be? Negative 4, right 12. So now you're here. So this is what the line looks like. Well, you can make a right triangle out of that, where it's up 11, right 12. So this is like an angle of elevation. That means that the tangent of theta equals opposite over adjacent. That is going to be inverse tangent 11 over 12. So we talked about this. Tangent equals slope. So tangent theta equals slope. So theta equals inverse tangent of the slope. And you can go straight to this every time. Inverse tangent of the slope. You don't have to draw it out. You don't even have to set it up. You need to know that it's inverse tangent of the slope. That's the only thing we care about. So we do inverse tangent, make sure I got the right answer here, of 11 over 12. And it says round to the nearest thousandths, 42.510. Yes. Emmy, Luis, and Shivani form a triangle. So let's do that. I don't know what they look like, but we got Emmy, Luis, and Shivani. The distance from Emmy to Luis is 5. The distance from Luis to Shivani is 8.5. Shivani was talking to Luis when she heard Emmy explain, "I'm a genius." So she turned and looked at Emmy. If Shivani must turn her head 32 degrees to go from looking at Luis to looking at Emmy, what is the distance from Shivani to Emmy? Okay, that's a fun one. Woo! So we got a few things we're going to do. We're going to look at this for a second. Do you see anything you can do? I'm going to drop a height right here. I don't want to break the 32. So you could have drawn this triangle any way you want, but at no point should you be drawing a line that cuts up the 32. You do that, then you don't have any angles anymore. Don't cut up your only friend here. So leave the 32 intact. And so if I focus on this orange triangle, let's call the bottom of that Y. Orange triangle, call this Y. This would be 8.5 and 32 degrees. Could I get that side on the bottom? And the answer is yes. That would be the cosine of 32 equals Y over 8.5. So Y equals 8.5 cosine 32. Okay, but that's just that distance from here to here. How are we going to get the rest of it? That's going to be kind of tough. I'm going to call this part over here. We're going to make a different color. But let's focus on this right triangle. Call this like W. Well, how do we do anything here? Well, what we could do is get this height. We have a way to get that from the orange triangle. So we have W, X, Y. We'll call this height Z. That would be this height here. So can I solve for Z? The answer is yes. To solve for Z, that would be the sine of 32 equals Z over 8.5. So Z is 8.5 sine 32. So in our picture here, this equals 8.5 sine 32. So now I'm going to draw the red right triangle where I know this is 5 and I know that this is 8.5 sine 32. So it gets really messy, but this would be a straight Pythagorean theorem. It would be the square root of 5 squared minus, in parentheses, 8.5 sine 32 squared. And that's how long W is. So what does X equal? X equals W plus Y. It's going to be this number plus this number. I'm going to type it into my calculator exactly like I wrote it. The square root of 5 squared minus parentheses 8.5 sine 32 close parentheses squared. Get out of the square root plus 8.5 cosine 32. A lot of work. Let me show you what my calculator screen looks like just so you understand what's going on here. Look what I typed in. Exactly like I wrote it. Square root of 5 squared minus parentheses around all that squared. Get out of the square root plus 8.5 cosine 32. And it rounds to 9.379. 9.379. Guys, I know that's not the only way to do it. There were definitely other ways to do it. That's just one way. If you're getting to this, I'm pretty confident you did things right. You're not going to accidentally get that answer. Non-calculator, 30 triangle, 30, 60, 90. Whoop! So we got 30, 60, 90 triangle. The hypotenuse is 16. This is 1 root 3, 2. So if the hypotenuse is 16, you divide by 2 to get 8, multiply by root 3. The short leg would be 8. The long leg would be 8 root 3. What is the area? Well, it's already a right triangle. So could we just do 1/2 times the base times the height? Yeah. That would be 32 root 3 when you clean that up. I don't know if this is going to confuse you, but could you have done like 1/2 times 8 times 16 times sine 60? Could you have done that? Yeah. Remember, it's 1/2 times side times the sine of the angle in between them. That is an alternate formula. You're going to get the same answer, right? Because, you know, sine 60 is root 3 over 2. It's going to work out the same. All right. 30, 60, 90 triangle. Let's get it. So we got 30, 60, and 90. The long leg is 18. So 1 root 3, 2. This is 18. How do you go backwards? You take the long leg and divide by root 3. Or, like I've showed you a few times, it's something times root 3 equals 18. So you need to divide the root 3 off. And remember, you got to clean that up. That's going to be 18 root 3 over 3. But wait, what is 18 divided by 3? It is 6 root 3. It really is my hope that you can go from this straight to this, or honestly, this straight to this in your head. We've worked at that. It's time to get good at that. It's time to practice it and try your best at that. So that would be 6 root 3 for the short leg, which means that the hypotenuse, if that's 6 root 3, then you double that number. That would be 12 root 3. So the area would be 1/2 times the base, 6 root 3, times the height, 18. And that would be half of 18 is 9. 9 times 6 is 54 root 3. Could you use one of our alternate formulas? You could if you know how to execute that. 45, 45, 90 rules. We haven't done this in a minute. So we got 1, 1, root 2, and they gave you a hypotenuse. So it's a 45, 45, 90, where you have the hypotenuse is 16. So you need to do 16 divided by root 2, right? We have the root 2. We need to divide by root 2. Can you do it in your head? Are you actually trying? It's going to be 8 root 2. I want you to try to figure that one out. I'm not even going to show the work. The area would be 1/2 times base times height. Now that could be a little messy, but that would be 32, right? 1/2 times 8 is 32. And then what is root 2 times root 2? That's 2, so that's 64. 32 times 2 would be 64. All right. Oh, yep, I remember this question. All right. Alfreda stole Srikar's favorite calculator. And I might have changed the people in the pictures a little bit, but it's the same general question, I promise. Alfredo stole Srikar's favorite calculator. When Srikar confronted him about it, Alfredo's like, bro, I don't care if you're 7.7 tan 40 feet tall and you have a 20-degree angle depression looking at me. You aren't getting this calculator back. If Alfredo was sitting 4.277 feet off the ground, how far is he from Srikar? All right, so this is Srikar, in case you're wondering, the guy standing, and this is Alfreda, the guy sitting. He says, I don't care if you're this tall. So that means Srikar is 7.7 tan 40 tall. So I'm going to kind of draw it over here. So this side would be 7.7 tan 40, the entire thing. That's how tall he is. And then we have Srikar looking down at Alfredo. So we'll say that this is Alfredo over here. It says Alfredo is 4.277 feet off the ground. It says that there's an angle of depression And I'm going to go ahead and make it an angle of elevation. So if it's an angle of depression from Srikar looking down, wouldn't it be the same number for Alfredo looking up? So how far is he from Srikar? That would be this number here. Call that x. So we need one thing. We need to know this value. Well, wouldn't it be the whole thing minus the 4.277? So I'm going to make another triangle. We know this is 20. We know that this is x. And this side is going to be 7.7 tan 40. That's how tall he is. Minus the 4.277. So what is the situation? It's going to be the tangent of 20 equals opposite, which is 7.7 tan 40, minus 4.277 over adjacent, which is x. If x is down low, they switch places, you know. So that's going to be 7.7 tan 40 minus 4.277 divided by the tangent of 20. Make sure I got the right answer here. I'm going to type this in. 7.7 tan 40 minus 4.277 over 7.7 tan 40 minus 4, yeah, over the tangent of 20. So I got 6.0006, which means you need to round it to 6.001. But it's basically 6, right? So he's basically 6 feet apart, but it's not quite. A little bit more than that. Well, announcements are starting. Hopefully we can finish this and you can hear me. Luis, here's Luis down here, stands up and starts trying to help Alfredo escape. If they run 3 additional feet before Srikar makes a move, what is Alfredo's new angle of elevation at that time? All right, so we have our triangle, right? It's still going to be 7.7 tan 40 minus 4.277. But this, I'm not going to rewrite all that. I don't know what I'm doing here, guys. Look at all this writing. Okay, I'm going to copy this. But this side is going to be all of that plus 3. So he ran 3 feet away before he moved. What is the new angle of elevation? So this is going to be tangent of x equals 7.7 tan 40 minus 4.277 over, dear goodness, all of that plus 3, right? Wouldn't that be opposite over adjacent? So our final answer is inverse tangent of all this. Just typing it in is going to be a chore. Do you know how to type it in? So inverse tangent, start my fraction key now. So we got one big fraction. On the top part of this big fraction, we have 7.7 tan 40 minus 4.277. Go to the bottom part of the fraction. I'm going to start another fraction on bottom. That is 7.7 tan 40 minus 4.277 divided by the tangent of 20, arrow over all that plus 3. There we go. Oh dear. I'm getting a different answer. Let me look at this real carefully again. Luis stands up and starts trying to help Alfredo escape. They run an additional 3 feet. What is Alfredo's new angle of elevation at that time? So this was 7.7 tan 40 minus 4.277. That's correct. 7.7 tan 40, all that over tan 20. Add an additional 3 feet. That looks correct. So let me check how I typed it in. Oh, yep, I typed it in wrong. So that's why we got to double check things. Sorry, 7.7. Let's change that. There we go. Now I got it. So I do want to show you how I type it in, my friends. Woo! Look at all that. So I did, just so you know, like this is pretty beefy, but shift tangent, I started my fraction. I typed in the top stuff. I don't want to retype it all, but I typed in the top stuff. I went down, and wasn't there a fraction on the denominator? Yes. So I started another fraction down here, and that's when I typed in the top and the bottom. Then I arrowed out of that fraction to do my plus 3, which had to be on the bottom. So if you take a look at this, like if I scroll through all this, there's the top, there's the bottom, the plus 3 is on the bottom. That's what it looks like. I'm not going to make you do something that crazy on the test, but like that's, you know, that's some good math there. Comes out to 13.640 when you round. Woo! That was a fun question. All right, guys. I'll see you next time.